Okay, so we will start the class, right? So, in our last class, we were discussed about the counterings, right? Is there any doubts regarding countering? We have two methods. One is the direct and indirect method. So, as you know, already I told you that direct method is what are the values we are getting for the each and every station. Based on the values, we have to join the line, one of the imaginary line, right? So that is meant by direct method. Whereas coming to indirect method, so already we are fixing the values of for the contour lines. That means I need to draw the contour line of 100 meters, right? If the values, whatever it may be, what you are getting is not a thing, right? We need to draw a one of the line with the elevation of 100 meters. So that is our aim. Okay. So that means here we are going to do the interpolation method to get the where we are getting the 100 meters of elevated points, and that we are going to join one of the line with smooth hand curve. Okay, by using a free hand we have to join with a different shape of parabolic curve. Okay, so that is the difference of direct and indirect method. And direct method, excuse me, excuse me, wait a minute. Sorry for the inconvenience. In that case, I mean, within the indirect method of contouring, so we have a various conditions was there. One is we first of all we need to form a grid line, right? Of then what we are doing each and every intersection, where we have to find the RLs by using of different ways. We have a different equipments was there, auto level, fly level, theodolite, total station. Okay, so we can use any one equipment as you know how to use the equipments. Okay, so first of all, before we are going to operate the instrument, we should level the instrument and locate the centering point. Centering and leveling is a must and should. Of them only we go for the to locate the each and every station by placing of the leveling staff. Okay, after placing the leveling staff, then you have to direct and note down the readings of which it was shown. Okay, so when we are going to direct your leveling staff, your telescope should be in a horizontal, right? When it should be horizontal, how you can able to know the whether the telescope is horizontal or not? In the fly level or auto level, it was fixed. There is no movement at all, right? I mean, it should not move in a vertical position, vertically. Okay. Whereas coming to here in the theodolite or total station, it may rotate throughout 360 degrees. Okay. So in that case, how we are going to place exactly horizontal, right? So that means within the vertical scale, whereas coming to if you are taking the theodolite, so within the theodolite already we have a vertical graduations was there with the vernier C and D. Okay. When you C and D, when you C value should, when you C as well as a D should be exactly 0 degrees, 0 minutes, 0 seconds. If we can place like that, then it shows that the telescope will be perpendicular to the plumb bob line. Okay, so perpendicular to the plumb bob line in the sense that is meant by horizontal, otherwise parallel to the earth surface. Okay, then only you have to focus on your leveling staff to direct the leveling staff, then bisect and observe the cross edge where it was bisected on the leveling staff. That you have to mention. So, as you know, as at most first value we are placing on the back side and last reading placing on the foresight before we are going to shift the instrument. Okay, so before we are going to shift the instrument, the whichever reading we have taken, that is the foresight, and remaining in between first and last, that we are considering as a intermediate side. And two methods was it. One is the height of instrument method and one is rise and fall method. Based on the two methods, any one method, use any one method and calculate the RLs of each and every station. Okay, finish. So we have calculated the RLs for each and every intersection points and each and every station. Then what we are doing, we need to look at the where we are getting the 100 meters. Okay, where we are getting 100 meters. So for example, if you have an in between the line, I mean intersection points, one is 99.1, other one is 102.3, right? So 99.1 and 102.3 means, so difference. First of all, we take the difference and form a grid lines, right? So within that, each and every line carries some distance. Okay, that means the difference divided by the how many lines we have, that is a 10, divided by 10 just then you will get the value. So that means each line carries that much of value. So based on that, where we are getting the 100. Otherwise, you go for the interpolation method was there directly. Okay, if you are going to draw within the graph means, then you can able to easily find the value of 100 where we are getting. If you are drawing on the any chart or paper means, you go for the interpolation method itself. Okay, so each grid line as you are going to mention the some distance. So based on the distance, by using of interpolation method, you will know the distance from any one point. If you are going to take from 99.1 onwards or 102.9 onwards. Okay, so whatever it may be, it will give the value based on the value which you have taken. Okay, so that is, and also we have a radial sections for the pond and reservoirs was there. Okay, so you can use any one of the method to calculate the distance. Then you have to join the, I mean, after locating the each and every stations of where we are getting the 100 meters of elevated points, then we have to join a one of the line by using a freehand curve. So that is made by in indirect method of contouring. So what is the difference between direct and indirect method means? In the direct method, so what are the values we are getting? Such as same values. Based on the values, we have to join a one line. Okay. And indirect method means already the elevated points was fixed. Okay. So that means if I am going to, whatever it may be, we don't know the, before we are going to test the experiments, right? Before we are going to test, so we already fixed the contouring lines. So these are the contouring lines you have to draw here. So that is the indirect method. Okay. Next, from the second unit, third topic is computations of area and volume. Computations of area and volume. That means when we are going to calculate the value. So as you know, first of all, if we are going to excavate one of the pit, what is the purpose we are going to excavate the pit? So to know the properties of the soil as well as to know the quantity of the soil and its density. So as you know, what is the density formula, right? Density equals to mass by particular its volume. Okay. If you know the mass and density, okay, if you know the mass and density, based on that, you can able to calculate the volume by using the density formula. So the same way here also, when we are going to excavate the soil for canal or tunnel, right? For distribution channels, for that case, or otherwise any embankment for the ponds, okay? Otherwise for banking of the roads, banking of the railway tracks, okay? And reservoir bankings. For these all conditions, we should know the how much quantity we have to excavate as well as how much quantity we have to fill. ఓకే సో ఎంత ఫిల్ చేయాలి ఎంత ఎస్టిమేట్ చేయాలి అనేది మనం ఇక్కడ క్యాలిక్యులేట్ చేయాలి రైట్ సో దట్ మీన్స్ వీ షుడ్ నో ద ఏరియా ఫర్ different shapes as well as and its volume. Once if you know the area, multiply with volume means length means then you'll get the volume, right? So that means you can able to first what is our aim? We need to calculate the area. Okay, so that we are going to learn by using our second new third topic, that is meant by combinations of area and volume. See here, measurement of area. As you know, volume is area multiplied its length, then you will get the volume, right? Here, how we are going to calculate the area for different shapes. As you know, if I am giving you one of the area, whether it is pond or reservoir, water it may be. So what is the basic principle of surveying? The basic principle of surveying is to form a possible way of triangles or right angle triangles. If possible, right angle triangles we have to make, otherwise possible way of triangles. Right? It's the same thing here also. Complete field, whatever it may be, right? Whatever we have written. So in that area, we form a possible way of triangles. As you know how to triangle the area of a triangle, right? Using of that, we can able to do the conditions. So that is the basic principle of surveying. Whereas coming to here, the measurement of areas and volumes, not only for the splitting of triangles. Here, any geometrical figures. See here, by field measurements, by dividing the area into geometrical figures, right? Geometrical figures means rectangle, square, right? Triangle, pentagon, polygon, right? And hexagon, circles, okay, like that. So there are the geometrical figures here. First, before we are going to split or divide any geometrical figures, we should know the baseline. Only you have done in your chain surveying. So what is the baseline? Right? So within the chain surveying, I mean by using of chain survey, you are going to calculate the area. That means you know the offset distance, right? Offset points. how, as you know, by using of crosstab, you have located the outside points and know the distance by using of tape, right? And where you have laid one of the chain. So that is meant by baseline here. Okay, so that is the baseline. That means based on the baseline only you are going to calculate the distance. And double meridian distance. Meridian, right? So meridian is different here based on the one axis. Okay, so based on the horizontal or vertical. Generally, four coordinates was there, right? Here, within the double meridian distance, what we are doing means, example, you have to take a one rectangle, right? Within the rectangle, as you have taken here one of the side, the side distance is called meridian. Okay, that means at the center, total distance we have taken as a latitude and departure. So instead of x and y, here what we are doing is latitude and departure. Okay, so that are the things that will happen in the double meridian distance, and based on the vertical line. Vertical means latitude, right? So our latitude nunchi, what is the distance from latitude line? So that is a, we are assuming that is a true meridian line, right? So here the latitude line on itself, how much distance that we are calling as a L1. That is a latitude distance that we are considering as a meridian distance. Okay. And next coming to the next one is by plan measurements. Okay. So here, as you know, how one of the plan was there, and how you have divided the so many triangles and calculate the area. Computations based on the measurements scaled from plan or by using a planometer. So planometer generally is used to calculate the distance as well as angle, right? And here, how we are going to calculate the area for different geometrical figures. See here, for the triangle, what is the triangle formula? Half into base into height, right? Here, half of the perpendicular height multiplied with base. So perpendicular height, and baseline is the one thing, and this is the half of the perpendicular height. Baseline to perpendicular, right? So this is the half of the perpendicular height they have given here. That means half into base into height. And next, parallelogram. Parallelogram is nothing but rectangle. So rectangle means opposite sides are has equal lengths. In the parallelogram also opposite sides, but it was leaned some angle, right? It has leaned some angle, but we are not going to consider that one. So opposite sides are equal. That's why we have taken as it. That is the rectangle formula base into perpendicular height. Excuse me. Okay. So next trapezoid. Trapezoid. Okay. So what is the trapezoid formula? Already you have calculated in your laboratory also. So that is the formula of h by 2 into a plus b. Means a, b are opposite sides and h is the base, right? Half the sides, that means half of the sides, a plus b by 2 into height, h. Next, trapezium. So trapezium and trapezoid are both on one side, but area will be defined such a same. I mean, we have the possible that trapezium we have divided into the triangles. Okay, so the trapezoidal itself, it was example if there is, say here in this figure you observe A prime, B prime, C prime, right? And capital A, B, C are one of the trapezium. Okay, so this trapezium, what I am doing is I am going to split the like this here to here. Okay, so what will happen? So this is one of the rectangle and this is other triangle. Like that we have to divide it and calculate the area. Okay, so there is a second name here, trapezoid, trapezium, and regular polygons. So regular polygon itself, right? Length of the perimeter. Perimeter, as you know, that is the length of the total outer side. Length of the perimeter multiplied with half of the perpendicular distance from center of the sides. So that I have given here one of the formula, right? So this is not a constant one. The figure will decide the formula. N is the number of sides and L is the length of the one side. See here. Next, area of the offsets. See here, area of the offsets. Offset, we need to calculate the offset area, right? That means within the chain surveying, calculate the area, right? By using of offsets only. So such a same thing, such a same procedure we have to follow for the calculating of the area of offsets. Okay, where it is triangle or square or trapezium, whatever it may be, as you know how to calculate that one. Already you have practically done in your laboratory. Okay. So next coming to the, here we have a formulas. How we are going to calculate the area for the different sections. That means in our laboratory we have calculated the area for irregular sections, right? And these are the formulas. That is mid ordinate, right? Mid ordinate or average ordinate rules. These are the things for calculating the area for roadways or canals. Okay, so that means the distance will be varied. If the distance will be varied, means automatically the area also varied, right? So see here the offsets H1, H2, Hn are measured at the midpoint of the each division. Okay, so that means one of the trapezium was there, right? Each and every point we have calculated the distance h1, h2, h3, that are the mean height or mean depth of the channel or canal. Okay, so first of all we have to calculate the mean height, the h1, h2, hn. Okay, so on average ordinate, that means h1 to hn divided by number n. So in terms of out divided by n multiplied with its particular length. If the each and every side length has same, then we can able to use L directly. Okay, L equals to, how we are getting the value of L, right? L equals to N into D. Observe that one. n is the numbers, how many numbers we have taken, and d is the distance, right? So this is the mid ordinate rule. There is the average ordinate rule also, right? And here, see this one. Here we have a calculator only for the H1, H2, the average. I mean, only mean depth was averaged here and multiply with length. That is, as you know, the formula for area. That is the length into breadth. So the same formula we have used here. Okay. So total mean depth ఏదైతే ఉందో దాన్ని mean చేసుకొని average చేసుకున్న తర్వాత multiply with length use చేసాం. Okay. And next coming to the average ordinate rule, right? So first of all, we need to calculate the ordinate distance, right? O1, O2, O3. That is meant by O1 in the sense that is the opposite sides, everything on my right? Small a plus small b by 2. So that we have to average the value we have given as say O1, O2, O3 and ON. Okay? So measure at end of the each division and are spaced apart here at equal distance. So that means equally distance we have spaced here. Equally distance we have placed here. Then see here the formula is O1 to ON multiply with L. Here we have used only divided with N, but we have here N plus 1 terms was there. Okay, N plus 1 terms. That is meant by area is summation ND summation of O divided by N plus 1. Okay, so this is the average ordinate rule. Just we can use as this formula directly and calculate the value. And trapezoidal rule, right? So trapezoidal rule, see here, area for the first trapezium, area for the second trapezium, area for the last trapezium. For example, see here, formula, observe here, d into distance is the same distance as we have provided for each and every divisions. O1 plus O2 divided by 2. That means average of two objects, successive objects, and O2 plus O3 divided by 2 plus so on. ON minus 1 plus ON by 2. So that means we are going to averaging of the successive ordinates, then multiply with the distance. Okay. Next, Simpsons 1/3 rule. Okay. See here. So actually the shape was, this is the shape. Okay. So capital A, B, C, and this is the ordinate of O1, O2, O3. Okay. So actually the curve will be like this. This is the parabolic curve, right? Instead of that, right? Instead of parabolic curve, what we have taken is we found one of the trapezium. That means I know how to calculate the area for the trapezium, right? So that's why I have made one of the trapezium for this section. That is the I have extended from A to A prime, small b to as usually b prime was there, right? And C to C prime, and join here one of the line A prime to B prime and C prime. Now I have calculated the total area for this trapezium. That is the A prime to A, B, C, and C prime to B prime to A, right? So this area has calculated easily. As you know, the ordinates are O1, O2, O3. Okay. So H by 2, that means O1 plus O2 by 2 into D. Saying O2 plus O3 divided by 2 into D. So that is the area for these two trapeziums, right? So for this section is, for the AB to AB prime is O1 plus O2 divided by 2 multiplied with distance D. So this is the base here. And these are the opposite sides. That means small a and small b. small a plus small b by 2 into baseline. O1 plus O2, average of two ordinates, right? Successive ordinates multiply with distance d. Same plus with addition of that O2 plus O3 by 2 multiply with distance d. Okay, like that we have calculated here two sections. The BCM was calculated. Next, we have to deduct this area. That is a triangle. I mean, you have to observe this is it look like a one of the triangle, but the curve not in a linear, right? So there is in a parabolic curve. We have one of the formula was there. Totally 47 members now, right? So we have to deduct this area. Okay. So there is a triangle of A prime, B prime. But we should not use the triangle formula here. Why? Because the curve at the hypotenuse curve is varied, not in a linear. It was looking like a parabolic curve. Okay, such a same thing here also. We have to get this triangle area. That is the C prime, B prime. Okay, so that they have given here. Series one, Simpsons one third rule. There is a area of trapezoid. That is the O1 plus O2 into 2D by 2. Okay. Next, area enclosed by segments CIDHC. So two-third of that means this area, right? A prime B. So that is the area of two-third into area of parallelogram CDEF, right? So actually the name, I mean notations was different, whichever it was shown here and the figure. Okay. You don't bother about that one. So that means we need to calculate this area. That is the two-third of the base into height and two-third of the base into height. As you know, what is the distance, right? So what is this distance? So this is the from here to here O1 and here to here. What is the length? O2 minus O1, right? So what is this distance? This is the O2 minus O1, right? So if you work O1 and this is the distance of O2 minus O1, then you will get this distance. So that's why they have given here O2 minus O1 plus O3. That means we have to add up this another distance also, right? So into 2D by 2. Why? Because 2D means we have a two triangles was there. Okay. So that's why they have taken as a 2D into the area of first two divisions. To third multiply with O1 plus 4 O2 plus O3. See here, the first coordinate and the last second coordinate. Second coordinate has a product of 4, right? With the product multiply with 4 was there. Like that we have to add it. So finally the area formula by using of Simpsons rule, the area formula is d by 3 is common thing. It is parabolic curve కాబట్టి that's why d one third of distance, that means d by 3, and first and last ordinate was free from అంటే అవి ఓన్లీ సింగిల్ గా ఉన్నాయి, right? So O1 plus O1, that is the first and last ordinate plus 4 4 multiply with even ordinates. So these are the even ordinates. Okay, and next, and these are the odd ordinates. 2 multiply with odd ordinates. Okay. So this is the formula for the Simpsons rule. You have to remind that one. area equals to t by 3. T is the length of the division, right? So d by 3 multiply with first and last ordinate summation of 4 multiplied with even ordinates plus 2 multiplied with odd ordinates. Okay. Next, area from the coordinates. So that is meant by meridian rule. Okay. So how we are going to calculate the area by using the coordinates. As you know, for the each and every point has a coordinate of x and y distance. Instead of x and y, here given me there is a latitude and departure. Okay, so latitude in the sense we have to use as a L and departure D. X-axis we are going to consider as a D here, departure, and y-axis in the sense latitude L, right? Like that we have to latitude and departure. అక్కడ మనం x and y చెప్తాము, right? Because we have to represent in the latitude departure. Okay, see here. So within this figure, one of the section was there, that is the A, B, C, D. See here. This is a A to B, one of the line, right? See this one. So this is a A, B, C, D, right? So this is the actual figure. That means we need to calculate the area for this section. For this section, I have drawn a at the line of at the point of A. We have drawn a one of the vertical line, that is the latitude. Okay, so that I have drawn a one of the line. Based on this vertical line itself, I need to calculate the distance. I mean, I need to know the meridian distance. See here, A to B at the center half of the AB length, I have given a numbering of 1. Okay, I have given a number of 1. That is a center of the AB distance. Okay, I have calculated the distance, that is the, so D1, this is the total length of AB distance is D1, that is the departure from this meridian line. D1 x-axis is departure, right? So that is the distance of D1, departure D1. Okay, within this, so exactly I have bisected one of the line from the point of 1. Okay, so we have of half of D1. So half of D1 ni name anukunna, that is the meridian of the line. So that's why I have indicated M1 here. Okay, so M1 is the meridian of the line AP. And then the total distance departure from the line of itself from here to here, I have taken considered as a, that is the departure length D1. దాంట్లో హాఫ్ కన్సిడర్ చేసుకున్నాం కాబట్టి హాఫ్ ఆఫ్ D1 ఆ డిస్టెన్స్ ని మెరిడియన్ M1 గా కన్సిడర్ చేసాం. నెక్స్ట్ ఫ్రమ్ ద లైన్ ఆఫ్ B to C, you have to observe how they have provided the distance. Just glance once. మా అబ్జర్వ్ చేశారమ్మా ఫిగర్ని?
సార్ స్క్రీన్ షాట్ తీసుకోండి.
స్క్రీన్ షాట్.
సార్ తీసుకున్నా సార్.
Okay. See here. Complete AB length mean half the exact gap. And each and every side we have located the one of the center point that we have indicated a number of 1, 2, 3, 4. 1 is the center of AB line, and 2 is the center of BC. CD is, and DA is center of 4, right? So after given this points based on this line, okay, so I have given you one of the y-axis line, there is maybe latitude, right? So this latitude I have drawn it at the point of A. Okay, so once I have drawn this line from based on this meridian line, I have taken the distance of half the distance of AB, right? So there is a departure D1 is from here to here, that means small b to capital B. So small b to capital B, that means horizontal distance. So there is a D1. At the point of A is 0, right? So that's why I am not going to consider from the B point itself for the line of A to B. That is a distance of D1. Okay, so దాంట్లో హాఫ్ కాబట్టి half the D1 half distance మాత్రమే నేనేమన్నా మెరిడియన్ డిస్టెన్స్ అన్నా. Okay, such a same thing for the BC also. So BC at the point of C వరకు నాకు ఏంది D2 distance. ఇక్కడ నుంచి from the B నుంచి C కి. See here from the A to B I have taken as a horizontal distance is D1. From B to C also horizontal distance. Okay, so horizontal distance is D2. Within that, at the point of 2, I have taken as a half the distance, half of the D2. అంటే నాకు మెరిడియన్ లైన్ ఎక్కడ నుంచి based on the axis. So ఇక్కడ నుంచి ఇక్కడ వరకు. That means what is the M2? M2 will be equals to D1 plus half of D2. Right? So D1 plus half of D2. That is the M2 value. అంటే టోటల్ డిస్టెన్స్ ఇక్కడ నుంచి ఇక్కడికి నాకు D1 అన్నాం, రైట్? సో అండ్ ఇక్కడ నుంచి ఈ డిస్టెన్స్ ఎంత? దట్ ఈస్ ద హాఫ్ ఆఫ్ ద D2. సో D1 plus D2 is the M2. నెక్స్ట్ మళ్ళీ మనము ఈ మెరిడియన్ నుంచే కన్సిడర్ చేయకూడదు, రైట్? సో వన్స్ ఐ హావ్ పాస్డ్ ఫ్రమ్ A to B, B to C means now the meridian line is C. Okay, so now you are going to consider as if this is a one of the imaginary meridian line at the point line passing through the point of C. Okay, సో ఎంతసేపు మనం ఏం చేసాం, ఇక్కడ నుంచి మూవ్ అయ్యేటప్పుడు ఇది మెరిడియన్ కన్సిడర్ చేసాం, ఇప్పుడు ఇక్కడ ఇది మెరిడియన్ కన్సిడర్ చేసుకొని, రైట్? సో నౌ సీ దిస్ వన్, సి దిస్ వన్, వాట్ ఇస్ సిడి లైన్. సో సిడి లైన్లో నాకు సిడి డిస్టెన్స్, సో ఈ హారిజాంటల్ డిస్టెన్స్ ఏంటి? D3. సో హాఫ్ ద డిస్టెన్స్ ఇస్ హాఫ్ ఆఫ్ D3. కానీ మన మెరిడియన్ మాత్రం ఇక్కడ నుంచి కన్సిడర్ చేయాలి, డిస్టెన్స్ మాత్రం ఇక్కడ నుంచి తీసుకోవాలి, డిపార్చర్. సో డిపార్చర్ I have taken as from this axis, that is the from C to D is D3, but meridian is from here to the center line. So what about M3? M3 will be D4. D4 plus half of D3, right? So that is the distance of M3. So the same thing next from D to A. D to A is the distance of, all the distance is capital D4, half that half D4. Okay, so center వరకు నాకు మెరిడియన్ నుంచి, so this is the M4. Now I know the what is the M1, M2, M3 as well as M4, right? So this is the area formula. Area of triangles plus area of trapezoids, right? See here, this is one of the area A, B, D, right? So otherwise, you go for the C, small c, capital C, B, B. So this is the one of the trapezium, right? So this is a one of the trapezium. Within this trapezium, we need to neglect the area of this triangle. Books, yeah. Okay.
మీకు ప్యాకెట్ అన్ని చేయొచ్చు
Even please చేయలేదు
ప్లీజ్ చేసేసి
కవర్ ఎక్కడ ఇలాగా బైండింగ్ ఎక్కడ పేపర్స్
వాళ్ళు నిన్ననే చెప్తాను సార్ డేట్లు
చెప్పండి బైండింగ్ కావాలి అని చెప్పండి
ఓకే సార్
అప్పుడే సైడ్ ఓకే see here అన్ని బుక్స్ సేమ్ అలాగే ఉండాలమ్మా
हम कीड़ा सर ये छेरा मान खाओ दे 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 नहीं कोरी कचा मत कर छोड़
बालाजी
नहीं कोरी हाथ कालन रम्मत
సరిగా
काच धरानो
ఇంకెవరికైనా ఇన్ఫార్మ్ చేయండి ఆ బాలాజీకి రోజు మా సౌండ్స్ బాలాజీ ఆయనేనా
लग जाए मुझे
మురళి
फोटो फोटो ना है लागत
మురళి అబ్బాయికి ఫోన్ చేశారా
చేస్తాను సార్
बगल फाड़ रसू ए अगर ऐसे ही रमला रमला रमला
It's okay. Listen. See here. In the given figure, right?
बाट लगा तो सामने जो
అన్న ఇన్ఫార్మ్ చేశారా లేదా
ये के पढ़ बैठो जब तो ना है जा पुत्रा जो देख देख जो नहीं करते रो
See here, in the given figure, longitudinal of BC, right? That means I need to calculate the first of this trapezium. Okay, so that is a small c to capital C and capital B to small b, right? So this is the one of the trapezium, and another trapezium is small c to capital C and capital D to small d. So this is the other trapezium. So that means I need to calculate the area of A, B, C, D. Okay. So within this, I have taken two trapeziums. So one is this one, another one is this is the other trapezium. Okay. Now I have calculated two trapeziums. So I need to deduct the area of the triangle ABD as well as ADD. So because I have totally calculated these two trapeziums, including of this area also, right? So ఈ ఏరియాని డిడక్ట్ చేయాలి. Okay. So that are the two areas of one is the A capital D small d and A capital B small b. See here. So that is the departure and latitude. Departure and half of the latitude. That is the departure D5 into L4. Not like that. Just you have to observe here. So there is a departure. So this is a D1 distance, and here to here, what is the distance? D3 plus D4, CD distance. I mean small c capital C distance is D3 plus D4, right? As you know the opposite sides. So this is a small a you have to consider, and this is a small b half the distance, right? And this is a latitude, b c distance. Instead of that, we have to use as a one of the meridian lines. Okay, m1 areas use చేసుకొని we need to calculate the meridian and latitude or departure. Based on that, you can able to calculate the area. See here, for the area of triangles, D1, L1, that means departure and latitude for the first section, first side. So half into base into height plus D5, D4, I mean both are D4 only itself, right? So D5, L4 by 2. So this is also one of the triangle, and D3, L2 by 2. So D3, L3 by 2. That means some of areas will be added and one thing is directed. So the same thing for that trapezium also. See here, L1, L2. That is the opposite sides of the trapezium, latitudes. So దాన్ని average చేసుకొని then we have multiplied with T2. So the same thing here also. D4, L3 plus L4 by half the two things. Instead of this lengthy calculation, we can use as a meridian lines. Based on the meridian, we can able to calculate the area easily. Right? I mean, next class I will tell you how to calculate the area based on the meridian lines. Okay. Planimeter, as you know, so already we have discussed in our I mean contourings, right? So this is the equipment for the planimeter. See here, here the graduations was there. I mean, how we are going to keep the line based on these two lines. So here we have one of the scaling, and this is the another section. Based on this, we have to bisect the point and know the angle between the two lines. Okay, so here the show it shows the representation of the angle, how we are going to make the line between the angle between the two lines. Okay, is there any doubts how to calculate the area? I think so it is very clumsy, so you need to go through this ppt, I mean this pdf file. I will give the clear clarification in our next class if you have any doubts. Okay, I will share this PDF right now, and just go to this one and ask me the doubts in our next class. Okay. Is there any doubts? Okay, if you don't have any doubts, miss, just mention the attendance in the chat box and left meeting.